Let's go on to memory-based neural networks. Memory-based on process of association. We know that the human brain, which stores and retrieves information, is aided by process of association. A couple of examples. First, remembering Chinese or Japanese persons' names are usually based on the association of meaning rather than pronunciation. Secondly, memorizing telephone numbers is generally based on sequencing, symmetric properties, partitions, rhythm, and others. For example, the Japanese name Kazu Nakasawa, the meaning of gentleman's name is swimming in the middle of a river. Let me tell you a story how I remember Professor Kazu Nakasawa's name. The first time we met, he gave me his name verbally. Since I neither speak nor read Japanese, I could not remember it. Subsequently, on many occasions at various international conferences, this Japanese scientist always greeted me by name. It was embarrassing for me to constantly ask for his name. Finally, he gave me a business card with Japanese characters, which are incidentally identical to Chinese characters. Then suddenly I saw in those characters that his name means a gentleman is swimming in the middle of a river. This association made it easier for me to remember his name. I still remember his name today, even though I have not seen him for many years. In fact, associative memory is one of the best techniques for storage and retrieval of information in the neural net. The reasons are, first, they are capable of retrieving information from partial or erroneous input, and secondly, the robustness in noise and distortion, and third, the ability to select closeness or similarity of information. Let's look at one more story. Another interesting example of memory aid. A few months ago, I saw a segment on the CBS program 60 Minutes about a young boy in the United States who can remember over 100 digits of pi. Immediately, I felt that there must be a method that the young boy used to remember the sequence of numbers. I wondered, was he associating the sequence of digits with music or a picture, or if he permuted the sequence into arrays of numbers. As we know that every problem has multiple solutions, one of the solutions we discovered is as follows. Look at the sequence of numbers in pi. If I try to actually remember the sequence of numbers as it is, it would be a daunting task. However, if I permutated the sequence of numbers into a list of 10-digit arrays of numbers as follows, and here you see the 10-digit arrays. Now, if we treated these arrays of numbers as 11 telephone numbers, then they are not very difficult to remember. Thus, we see that by simply permuting a long sequence of numbers into arrays of numbers, it makes it easier for us to remember a long sequence, whereas 100 digit of pi seems impossible to remember. This is just a simple example to show that by using smart association process, one can increase the neural information storage capacity. This illustration also shows the inherent capability of a human brain which can process two-dimensional information formats more efficiently than a one-dimensional representation. I will discuss this subject later.